Okay, the numerical is a simply supported beam of length 25-meter long carries a uniformly distributed load of 5 kilonewton per meter on its entire length. Draw the SFD and BMD of the beam, shear force diagram and bending moment diagram of the beam. Okay, so I have taken the sketch which we used for explanation earlier. So this is my beam and the load per unit length is 5. So I'll just put this as 5 kilonewton per meter length and the length of the beam is 25 meter. Okay, now first thing I need to do is find the support reaction. So in order to find the support reaction, this is a symmetric case, right? So first let me convert this as a point load at the center. So that will be equal to W is equal to 5, or I'll write it as like this, W into L. So this is 5 kilonewton per meter into 25 meter. So that is 5 into 25, 125, 125 kilo Newton, right? Say this is kilonewton per meter into meter, so it becomes kilo Newton. So 125 kilonewton force is acting at the center. So from this I can write Ra is equal to Rb is equal to capital W by 2, which is equal to 125 by 2, and that will be 62.5 kilo Newton, right? So Ra and Rb is 62.5 kilonewton each, acting in upward direction. Okay, now let us first draw the free body diagram. Before that, draw lines like this from all the salient points. Now here I have only 3 points. One is at the center and other two are at the ends. Okay, now I will first draw the free body diagram like this, and on this I will just show the right. These are the two support reactions. Uh, and I'll just name them RA is equal to this much and RB is equal to this much. Right? So I have the reactions at the support and there is UDL still here on this. Okay. Uh, just copy this and put it on this as well. Right. Now let us first start with the shear force diagram. Now in order to find the shear force, I need to first uh, consider a section here as ZZ at a distance of X from support A, right? So at this section, what is the shear force and bending moment we'll find, and using that expression, I'll find the value of shear force. Okay. Now, SF at uh, section ZZ at a so X meter from A. Okay. So SFX is equal to, it will be W. I have the reaction, right? So RA minus of W into X, right? So the force here all of the UDL in this length is W into X. So this W is 5 and X is whatever value it is. So if you substitute this, it will be 62.5 minus W is 5 kilonewton, 5x. So the unit of this will be in kilonewton. Now from this I can find shear force at A is equal to, or first I will say, uh, yeah, 62.5 minus 5 into x. X is 0 at A. So 5 into 0. So that will be equal to 62.5 kilo Newton. Then SF at B is equal to 62.5 minus 5 into this entire length, that is 25. So this will be equal to 5 into 25 is 125. So 62.5 minus 125. So it will be minus 62.5 kilo Newton. Right? So the shear force at A and B are equal, but they are opposite in nature. So how to draw the shear force diagram? Now for drawing the shear force diagram, what you have to do is first draw a horizontal line. This horizontal line is representing the neutral axis of the beam. Now I need this line represents 62.5 kilonewton force. So At A it is positive side shear force is taken in upward direction. So this is 62.5, and at B it is minus 62.5. So I am putting it in the downward direction. This will be minus 62.5 kilonewton. Now what you have to do, like we have discussed earlier, the shear force varies linearly along the length of the beam. So I just joined this point and this point because I do not have any other load other than UDL on this, right? It is very simple numerical. That's why it has come like this. Now you just have to put this as plus and this as minus. This is positive shear force. This is negative shear force. Now having found the shear force, now next step is to find the bending moment and draw the bending moment diagram. So again we do this bending moment at section ZZ, right? So that is BM X. It is at a distance X from A. That's why I'm taking it as X. Now for bending moment we will use the sign convention. I explained this yesterday. I am telling once again. So this is very simple method of remembering the sign convention. You will never make mistake in this. So you draw a plus sign like this, and on this here you write left, left, here you write right, here you say clockwise, and below this is counterclockwise, right? Now left side clockwise is always positive, remember this, right? So here I will put plus, the opposite diagonally it should be plus, this will be minus, and this will be minus, right? So you have to remember that if this is positive, this will be negative, this is negative, this will be positive, and diagonally it will be same, left and right. If you want you can swap, but this is the usual convention that is followed across. Okay, now let us again go back here. I need to find the bending moment at X. I'll get a general expression. So Bm at X is equal to, now here I have a reaction which is equal to 62.5 kilonewton in upward direction, and it is making a moment in clockwise direction. This is my section at distance X. So it is on the left side making clockwise movement, left side clockwise movement, it will be positive, and the value of that is RA into X, right? RA is the magnitude of the force and X is the perpendicular distance. Then uh, this much of UDL, that is W into X, is the UDL which is there in this section. So I will write, and this is always acting in the downward direction. Force is acting in the downward direction. So downward direction, it is making counterclockwise couple or moment on the left side of the section. Left side counterclockwise, so it will be negative. So I will say minus the magnitude of the uh, point load of this UDL, right? I have to convert this UDL into point load, so that will be W into X, right? W into X is the magnitude, and it is acting at the midway of x. So into x by 2, right? So this will become wx square by 2. So now I will substitute the values in this. So this is 62.5 x minus w is 5 x square by 2, right? So this is my expression. Now in this expression, if I put x is equal to 0 and x is equal to L, I will get the bending moment at this section and this section, right? So Bm at A is equal to, I have to put x is equal to 0 in this expression, right? So 62.5 into 0 minus 5 into 0 square by 2. So this will become 0. The bending moment at A will become 0. Similarly, Bm at B is equal to 62.5 into x is equal to L now, and L is 25 meter minus 5 into 25 square by 2. Now 25 square, 25 into 25 into 5 by 2, right, is this much, minus 62.5 into 25. So that will also become 0, right? So this is also equal to 0. So the bending moment at both the supports is 0. Now I need to find the location of max BM, right? So how to find the location of maximum bending moment? I will use the expression for shear force. Ra minus Wx should be equal to 0, or 62.5 minus 5x should be equal to 0. So Bm is max, where Sf is equal to 0, correct? So 62.5 minus 5x is equal to 0, or 62.5 is equal to 5x हो जाएगा. So 62.5 by 5 is 12.5, right? Or x is equal to 12.5 meter. So x is 12.5 means it is the midpoint of the beam, like we have already discussed, right? And what is the magnitude of that? Bm, I've taken that point as C. Bm at center C is equal to, where is the bending moment equation? It is here, 62.5 into x is 12.5 now, minus 5 x square, 12.5 square by 2, right? Now let us calculate this. 62.5 into 12.5 minus 5 into 12.5 square by So this is 390.625. What will be the unit of bending moment? This will be kilo Newton meter, right? So this is the magnitude of the bending moment. Now I have to draw the bending moment diagram. So first draw a horizontal line, right? There is no negative bending moment, so I am pulling the line at the bottom. BM at A, that is at this point, is equal to 0. Bending moment at B, that is at this point, is also equal to 0. And bending moment at center is maximum, that is 390.625 kilonewton meter. So you have to draw a parabolic curve, okay? So you can draw something like this. It need not be exactly a parabola, something like this, and you have to write the values of all the. Now here I'll write BMA equal to 0, BMB equal to 0, and here BMC equal to 390.625 kilonewton meter. Similarly, here you can write value of shear force as 62.5 kilonewton, and here also it is 62.5 kilonewton. Since I have shown negative sign here, I don't have to explicitly write it as minus 62.5 here. Okay, please don't write minus 62.5. In the negative direction, it already means that it is minus 62 point, right? So this is the solution for the numerical.